Okay, we would like to introduce you to QLA's new digital depth gauge. This depth gauge will enable you to measure the paddle or basket height on dissolution instruments and record the value in your logbook. And the requirement, the USP requirement for that height is 25 millimeters plus or minus 2 millimeters. The gauge is a digital gauge, so it's very, very precise. It reads in hundredths of a millimeter, which means it has a test accuracy ratio of 50 to 1, which is extremely, extremely high. Other instruments available do not have the accuracy that this instrument has, and some of them do not even meet the minimum requirement, which is the NIST requirement for test accuracy ratio is a minimum of 4 to 1. So some gauges I've seen used do not meet that requirement. This gauge far exceeds it. So the gauge is serialized. Its part number is DDAPT, and it comes with a certificate of calibration which demonstrates the thickness of this bottom stem, and the thickness of the bottom stem is actually used in your calculation of the exact height. What we are going to do is measure a small displacement and add the thickness of this gauge to that displacement to get our final value. So let's see how the gauge is used. We have 3 instruments here, Hansen, Van Kel, and Distech, and we'll demonstrate it on all 3 instruments. 2 of them have paddles, 1 of them has a basket shaft, so we can see the difference there. And they've all been preset with the proper tooling. A lot of tools available for setting the height. We're not going to talk about those tools today. We're only talking about measuring the height. So we'll start with the Van Kel instrument, VK7000, and what we're going to do is install the measuring device onto the shaft. I'm going to lift it up until the bottom touches the bottom, or the top of the gauge touches the bottom of the paddle shaft. Turn the lock screw, connect it. Then we're going to lower the device to the operating position. Then we're going to come down here and take a closer look, turn the gauge on. Once the gauge is on, we'll zero it. And then we're going to loosen the thumb screw. We need to get a preload on the indicator. So we loosen the thumb screw and we run it down until we get, about somewhere in the neighborhood of 10 millimeters. Not important, just so it has a preload. You need more than 3 because we're going to be looking for displacement of somewhere in the neighborhood of 0 to 2, so you do need more than 3. I'd shoot for approximately 10, and then you're safe. So we've relocked the lock screw, and now we're going to zero the gauge. So we've got 0 on the gauge, and now we're going to lift the gauge lever. And we read 5.02 millimeters. Well, since we know the calibrated dimension for the bottom portion is 20, and we measured 5.2, adding those 2 together we get 25.2. So what I would record in the logbook for this position is 25.2 millimeters. Obviously passes, it's almost at the nominal. And then we would repeat the same process for all the paddle positions. When we're done, we lift the drive head. And remove the gauge. Now for basket's height, you would do exactly the same thing. We'll demonstrate that on the Distech unit down here when we get to that one. Let's just take a quick look at the Hansen unit, and we're going to do precisely the same thing. Temporarily put the gauge on the shaft here, slide it up till it basically contacts the bottom. I'll turn the gauge off for now. Lower the drive head to this preset operating position for paddles. Get down here where we can take a closer look. A little hard to see. Turn the gauge on. zero the gauge, and now loosen the thumb screw and come down and get that 10 millimeter preload, approximately 10, nothing critical about it. Okay, so now we got a little more than 10. Now I re-zero, I locked it in place, now I re-zero the gauge. Now I'm ready to take a reading. My reading here is 4.99. So adding 4.99 to the 20 gives me 24.99. And that's what I would record for this position, vessel position. Then I would repeat the process for all the vessel positions. Again, it passed very accurately. The gauge won't make it accurate. The setting will make it accurate, and this will measure and record that accuracy. Now let's go over and take a quick look at the disc tech. It's going to be the same basic thing. We do have a basket set on here just to show you the difference. It works on both. So we're going to put the gauge on, run it up to the bottom of the basket, tighten the gauge, zero the gauge, bring it down to the vessel, we are going to set for baskets on the disc tech instrument, bring it down to the operating position, and then we're going to come down here, take a close look, and we're going to bring the gauge down and get that 10 millimeters of preload again, approximately 10. Okay, we've got approximately 10, and I will zero the gauge. Now, by the way, when you zero the gauge, try not to touch the top of the base plate or any of the components because you'll influence the reading. And that holds true for all of the other instruments. So we've got zero on the gauge, and we're going to lift. 4.67. So what I have, adding 20 to that, I have 24.67 millimeters. And that's what I would record for this vessel position. And then of course I would go around and do the same thing on all vessel positions, and you will have very accurately reported the height of the basket or paddle shaft heights.